Myself Mydhili from Emmanuel J.J. College of Engineering, Department of Computer Science. Today I am going to teach about stack data structure. Already we have seen what do you mean by data structure. I am repeating the data structure. A data structure is a collection of files that are arranged in a linear order. There are two types of data structure. One is linear data structure, the other one is non-linear data structure. Linear data structure means arranged in specific order. Non-linear means it will arranged in any order. Linear data structure, example stack queue. Non-linear tree graph. Here we are going to see an example for linear data structure, that is a stack data structure. Is a very important concept and interesting chapter. So what do you mean by a stack? Stack is one of the linear data structure that follows a particular order in which the operations are performed. The order is last in first out. For example, we are keeping the book from last to top. Which one we are taking first? The first one we are kept will be taken out first. That is called as last in first out, which templates that the element that inserted last comes out first. First I am inserting 10 at the down, 10, 20, 30, 40, 50. So what element will be in the top? 50. So when we are retrieving, 50 will be taken out. That is called stack data structure. So it behaves like stack of plates where the last plate added is the first one to be removed. Pushing an element onto the stack is like adding a new plate on top. Popping an element removes the top plate from the stack. Here they are given an example for plates we are arranging. So last plate we are taking first. So pushing is nothing but inserting element into a stack. Popping is nothing but deleting an element on the top plate from the stack. Next, what are the use case of stacks? So finding next previous greater element, finding next previous smaller element, stack spam, iterative tower of Hanoi, evaluation of expression. So finding the next element, so finding the smaller element, how many elements of there. Next, Hanoi, how the arrangement of towers, evaluation of expressions. So this is two operations that we are using in stack. One is push, the other one is pop. Push, here see, push is nothing but insertion of element, pop is nothing but deletion of element. Push, here see, A, B, C. So which will be the top portion of the element? C. Which element we will take out first? C will be taken out first. That is called push operation. And there pop, A, B, C. So which one we are deleting? The top element is deleted first. Okay, that is called pop. So push means insertion of an element into the stack. Pop is nothing but deletion of an element into a stack. Now what are the applications of stack? So first one is function calls. What is mean by function? First we can see. Function is a group of classes that we call itself. Okay, manage return address to resume execution after function call. Each statement is called by a function in a program, that is called as function. Next one is recursion. What is mean by recursion? Recursion means it is a step-by-step process that by call by itself, that is called recursion. So track local variables and states during nested recursive calls. Next one is undo do operation. What do you mean by undo? We can edit and make changes. Redo means the same thing we can get back. The shortcut key for undo and redo is Ctrl plus Z. Next, syntax parsing. What is syntax? Validate syntax in programming and formal languages. Syntax means each program when we are writing there is a particular syntax. According to syntax only we can write the program. If syntax is missing, the program cannot be run by the user. That is called syntax parsing. Next, memory management. Once we are writing the program, where will be the program will be stored? The program is stored in the memory location. That is called as stored in the memory location. That is called as memory management. Okay, support dynamic memory allocation and deallocation. So there are two type of memory allocation. One is static memory allocation, the other one is dynamic memory allocation. So what do you mean by static memory allocation? Static means it will be not changed. What is mean by dynamic memory allocation? It will be changed. We can allocate the memory when we are needed. Okay, the function used for memory allocation is malloc. Malloc means memory allocation. What memory we need, we can allocate using that function malloc. Next one is function call. Stack manage the active functions in a program. When a function is called, its execution stack is pushed into the stack. When it finishes, it is popped or returned control to the caller. So already we know function. Every program has a function. So when the function is called, what will the stack is, the execution part will be pushed into the stack. During the execution time, what the operation will be done? Push will be done. Once the output is retrieved, which the operation will be done? Pop the operation will be done. So example, in a program where main calls calculate bill, which then calls apply discount, the stack ensures that once the discount is calculated, the program knows exactly how to jump back into the middle of the billing function. So in the main function, there is a function called bill. So automatically in the bill there will be apply discount function. So once the program is executing, it is pushing the program into the stack. After that, once it is calculated, it will jump to the main function, back to the function. That is called as pop operation. Next one is recursion. Since recursion is especially function calling itself, the stack stores a snapshot for each call. So the program doesn't lose its place. So every call, the first call, the stack will store the output. The second call, the stack will store the output. So each call, the stack is storing the output. That is called recursion. So recursion is a function calling itself. Once again, the same function will be called. One time, different output you will get. That output will be screenshotted. That is called as recursion. Example, in calculating in a factorial, the stack stores factorial. For example, factorial 5 factorial means first it will calculate 1 factorial. That is 1 into 1 equal to 1. Next it will calculate 2. That is 2 into 1 2. Next 3 factorial means 3 into 2 into 1. 4 factorial means 4 into 3 into 2 into 1. 5 means 5 into 4 into 3 into 2 into 1. Each time the output will be stored first, but the same function will be called 5 times. That is called as recursion. Next one, expression and evaluation. Stakes are used by compilers and calculators to handle the order of operation without needing complex parentheses. Example, to solve a postfix expression 34 plus 5, a stack pushes 3 and 4, pops them to add them, resulting in 7. Okay, for example, I am giving 3, 4 plus 5. There is an operation. First in the stack I will push 3, 4. And what the operator is present? Plus. So I will add the two numbers, that is 3 and 4, and the result will 7 is pushed back into the stack. And now the result is 7 and above I will put 5. Finally, I will multiply the 7 into 5. So what will the answer I will get? 35. That is called as expression evaluation. Syntax position. Stacks are perfect for balancing symbols. They ensure that every opening bracket has a corresponding closing bracket. If there is a left parenthesis, there should be a right parenthesis. So in all the programs, example we can see in the print, there will be close parenthesis and a open brackets, and at the end close the open brackets and there will be a close bracket, that is called as parenthesis. Example, and IDE uses a stack to check code like if A greater than B. There are two brackets, then open print C, it pushes left parenthesis into the stack as it sees them. When it encloses close parenthesis, it pops the top element. So open means it is starting. So what operation will be performed? Push. Next, close means pop. The execution will be completed. The program will be terminated. So in that pop operation will be performed. So for the open parenthesis, push operation will be performed. For the close parenthesis, pop will be performed. Next one, memory management. The stack is a specific region of RAM used for automatic variable allocation. It is incredible fast because it only allocates and deallocates memory in a strict lost in first out order. So how the memory will be allocated? Lost in first out order. So last we are arranging, first will be in the stack. That management, the memory will be allocated. For the memory allocation, what the function we will use? malloc. Example, when you declare int x equal to 10 inside a Java or C++ function, the memory is allocated on the stack. As soon as the function closing brace is reached, the memory is automatically reclaimed by the system without needing manual cleanup. Advantages: time and memory efficiency. So what are the operations we have studied? Push and pop are the two operations. Push means inserting an element, pop means deleting an element. So push and pop operation in a stack can be performed in constant time 0 of 1, enabling efficient data access. They are memory efficient because they only store pushed element compared to other data structure. Okay, so how the element will be stored? 0 of 1. Okay, lost in first out, that is called as LIFO. Lost in first out, LIFO. Stack follows the LIFO principle, ensuring the last element added is the first one removed. Last element added, first one will be removed. The first one will be in the top of the stack, so it will be removed first. This behavior is useful in scenarios like function calls and expression evaluation. Next, what are the disadvantages of stack? Limited access. Elements in the stack can be only accessed from the top, which makes it difficult to retrieve or modify the elements in the middle. So, the only thing is we can access only from the top. We can't access in the middle. So, there is a disadvantage in the stack. Next, the potential for overflow. Pushing more elements onto the stack, it can hold results in overflow error leading to data loss. So once the stack is full, we cannot push the element into the stack. It will lead to data loss. Next, declaration of stack using linked list. The stack can be implemented using a linked list, a node structure class that contains data to store to the element. So linked list, there will be node will be created. Okay, in node two items are there. One is data, next one is data will store the elements what the data we are giving. Next means moving to the, it will point to the next node, that is called as next. The pointer reference top that always points to the current node of the stack. Initially top equal to null to represent an empty stack. So what are the operations of stack? Already I have given you two operations. One is push operation, and one is pop operation. Push operation adds an item to the stack. Unlike array implementation, there is no fixed capacity in the linked list. Overflow occurs only when memory is escorted. A new node is created with the given value. we can create a new node what value we are giving. So new node's next pointer is set to the current top. Okay, the top pointer is updated to point to this new node. Push elements into the stack. Here see, this is one node. The first, there are two columns, one is data, next one is pointer. Data means what value we are giving, that will be stored. Next one is pointer, will link to the next node, that is represented by a arrow. Okay, so what are the data items here? 11, 22, 11, 33, 22. That is called as data item. The next one is the pointer. First in there is a null, so this is the top. The 22 is pushed to the 11. Next 33 is pushing next 22. Like that it is pushing. The first node is called a head node. The last node is called a tail node. Next, same the pop operation. What is the pop operation? Removes the top item from the stack. If the stack is empty, it is said to be underflow condition. Before deleting, we check if the stack is empty, top equal to null. If the stack is empty, underflow occurs and deletion is not possible. Otherwise, we store the current top node in a temporary pointer. Move the top pointer to the next node. Delete the temporary node. If it is empty, we cannot delete the item. Okay. Pop elements to the stack. 22, 11, 11. So, what I need to remove? 11 will be removed from the stack. Thank you. Have a nice day.